Buonasera. Before I start, can you please raise your hand if you can't read this, if it's too small? Very good. All right, as you said, I'm Jonathan. I'm a software developer, Python developer at a German e-commerce company called Salute. We're based in Karlsruhe, and I believe we're hiring, so if you're interested in a job, come talk to me or this guy there after the talk. And I've fallen in love with Python about 12 years ago now, and since then it's my main language, and I do pretty much anything in it. A little bit about the format of the talk. This is mostly live coding talk. That means mistakes can happen and will happen probably. So I'm happy for suggestions and corrections from the audience. Please just shout them in. No need for Slido for that part. And in the end, I will put all the result on GitHub. All right. On to the actual topic, debugging. But if we want to debug something, we first need to have some bugs. So this is a function called sum of squares, which gets a list of integers and then squares each element and returns the sum. And I would expect that if I call that with 1 to 3, I get the same result as if I call it with 3 to 1. But if I call this, it turns out the first time I get 14 as a result, and the second time I get 28. Kind of weird. And I could now, to figure this out, I could either stare at this code for a long time, or I could maybe insert print statements everywhere. But especially if the code gets a bit more complicated, a good idea would be to insert a breakpoint. So if I do this, if I just call breakpoint here and call this again, then I will be dropped into PDB, the Python debugger. And from in here, I can now do a variety of things. I can step inside the sum function. I can go to the next line. I can look at the value of some variables and so on. I can go to the return value of this function. See that it returns 14. Go next. Step inside the second function. Next. I don't know. Look at the values. Looks normal. Look at the list. Oh, that's probably our mistake here. And then I can go see or continue to let the program run its course. But the talk is not really about this specific error, the mutable default arguments or whatever, but more about how this breakpoint thing works. So breakpoint, in case you've been around for a while, you might be familiar with the old import PDB, semicolon PDB.setTrace thing. Since 3.7 or perhaps 5.53, you can instead just call a breakpoint, which will by default do exactly the same thing, but it is also customizable, for instance, by setting an environment variable Python breakpoint. So let's do that. So I'm going to import OS, and then I'm going to insert into the os.environ dictionary Python breakpoint. And you can just set this to a dotted name, so I will just put my pdb.setTrace. And if we call the code again, we will now see that it sort of half crashes. There's a warning because it can't find my pdb.setTrace. So let's create this my pdb.py and create a function called setTrace. And maybe just print hello in here. I don't know. Let's call the code again, and now nothing interesting happens, but we get called apparently. And to make anything interesting happen, what we can actually do is import sys and call sys.setTrace again, but this time without underscores. And the sys.setTrace gives us a callable. At first, I'm just going to give it print as well. Thank you. And if I call this, we see that we get 2 times some weird print thing. I guess once for every invocation of the function, I get a big thing that is kind of starts with frame and has a whole bunch of information. And I get call. It's actually the string call. And we get none. We get this twice. All right. So what did we just do? This is we just set a trace function. These are basically hooks for debuggers and some other tools. And there's 2 kinds. There's the global trace function, which is the one we just set. This is set by calling sys.setTrace. And this is called whenever we enter a new scope. And it can optionally also return something. And if it returns a callable, that will be then set as the local trace function for this scope, which will then be called in at certain other times, as we'll see. So instead of setTrace with print here, let's setTrace with a function that I'm going to define now. Let's see, say gtrace, global trace function. And just define that as well. As we've seen, it gets a frame, it gets an event, and it gets some other argument. And let's have it say entering scope, I don't know. And finally, let's also have it return a callable, so we set a local trace function. And again, I'm just going to use print for this. And if we call this again, we get way more output. So if I scroll up a bit, here after the first function was called, we get this entering scope thing, and we get a whole bunch of a bunch of lines here. All have this line instead of call now. You can see that the line number alternates between 3 and 4 for a while, and then goes to 5. And then we have the last thing again, and that's this time a return event. And this time the second argument is not none, it's apparently the return value. So yeah, the events that we've seen until now are call and line and return. There's 2 more events. There's exception, which is triggered when an unhandled exception basically occurs in a scope. And there's also opcode technically, but I'm not going to talk about this. This is anyways not active by default, so let's just ignore this. And the second kind of object we've seen now, I've talked a bit about it now, is the frame. A frame is roughly an entry on the call stack of Python interpreter. It's sort of the interpreter state or the Python view of the interpreter state inside a scope. And it has references to the current code object. So like the bytecode that's being executed, it knows which line number it is currently in. It knows which file this code object came from. It has references to the local and global namespace. And if it's not the topmost frame, it knows it has a pointer to the previous frame. So basically, the frame inside of our sum of squares function there has a reference to the frame it was called from. All right, well, then let's, instead of returning print, return something interesting again. So let's define a new callable here, ltrace. And let's start doing something real. The signature is going to be the same as we've seen. And the first thing I want to do is I want to print every line that we're about to execute before we're executing it. And in order to do that, I need another import. I need the inspect module. And then we'll just open the file that the frame is currently from, basically. So with open inspect.getSource file, I think, of frame as f, and then we can load all the lines in this file. So that's line.rstrip to get rid of the new line characters at the end for line in f. And finally, let's print our current line. And that's just one of the elements of this list, which we have the line number. So that's f.line no, or I think actually it's -1 because off by 1 lists are 0 indexed, file line numbers are 1 indexed. All right. And if I call it again now, we see that we see a bunch of code lines here. We see the for loop 3 times because we have 3 elements in our list, and we see the header a 4th time because we check basically a final time if we have elements, and then we see we have no more elements. And again, we have twice the last line because once it's a line event and once it's the return event. And with that, I think we have all tools in our hand to build a real interactive debugger. Kind of like a REPL we need to implement. So for a REPL, we need a loop. And we need a read. So let's read some input. We can think of some prompt, my PDB maybe. And then we can respond to various commands. Let's start with the simplest possible. If the user doesn't input anything, we would just want to ask again. Continue. And let's see what happens now. We see we are on this line, and we can press enter, and nothing happens. And in fact, we can also press anything else, and nothing happens. Not very exciting. So let's give this more functionality. I think the first thing I need is a way to quit this without always pressing Control-C. So let's implement the Q command, or quit. And what this does is, we want to abort execution entirely of the script, which both PDB and our little debugger are going to do by just raising an exception. And PDB, I think, has its own exception. We can just raise, I don't know, a runtime error maybe. Let's try this again. And if we do Q, we crash. Nice. For the next thing, maybe we're going to step over a line.
that's basically what we did before without having a loop. So we just need to break out of this loop in order to wait for the next time we're going to get called. Let's try if this works as well. And now we can step over these lines here. Right. What else could we want? Honestly, open for suggestions, but otherwise, Inspecting values, very good, yeah. Right, so we want to be able to look at variables, correct? So for that, that's basically the case something, like some piece of some line, I don't know, some command maybe. We have enough time for writing out the full variable names. Exactly, and for this, we're going to need to evaluate whatever the user entered. So we can use eval command, except I think if we do this, then we will have the issue that this will be evaluated inside this ltrace function, which we don't want. So we can give eval as second and third arguments a global and a local namespace, which we have in f.globals and frame.flocals. And this returns a value, so let's capture that, and let's, if it's not none, print it as well. All right, let's call this. And now if we enter values, we get some, we get a printout of these values. All right, and we can go next and print maybe ls. Yeah. All right. I think what I want to do next is continue, so we don't crash all the time. And continuing basically means we want to stop debugging. And we could do this in two different ways. We could either kind of sort of set a flag, and if that flag is set, then always at the beginning of the trace function, just return and don't do anything. But I think we can just actually disable debugging because it's also it's quite performance intensive debugging. So our current local trace function is accessible on the frame as as the attribute f under trace, and we can just set this to none and break out of the loop, and then we should be able to continue. Let's try. It almost works. The only problem is we still have the global trace function active, so we're going to get reactivated for the next function call, so let's fix that as well. Which we can do again by sys.setTrace, and if you set trace with none, it will just disable the global trace function as well. Let's see. Yeah, and it continues running. One thing that I just noticed is that our debugger at the moment works different from PDB in that we start tracing only inside of the function, not actually where we put the breakpoint. And if you think about it, that also makes sense because the only time we get to set the local trace function is when the global trace function is called, and that is only called when we enter a new scope. So to fix that, we need to do a kind of a ugly hack, if you call it, or an elegant function call here. Sys.getFrame, sys.underGetFrame, that's the underscore means that you're supposed to definitely use this. And if you pass this a number, then you get the frame this amount of calls back in the call stack. So this is basically not the frame where we are here right now, but where the breakpoint call happened. And there we do the same trick that we did just now, ftrace, but this time we assign our local trace function. And if we try this again, we see that we now have this breakpoint in front of the print, and if we step, we will automatically step into this. This is also not that correct yet when it comes to, or compared to existing debuggers. So I guess we can fix that next. So for stepping, for the step command, basically we need to change the way that our global trace function is working by not always returning the local trace function, but only when we have previously issued a step command. So let's do that. I'm just going to use global variables here. If you would do this for real, maybe you would use a class, but yeah, don't have time for that. So I'm going to set a flag, step into true, and break so we get to the next step here. We need to initialize it here, step into as false. We need to mark it as a global here, otherwise we will assign a local variable of this name into. And finally, in the global trace function, we also need to
consider it. So if step into, then we return the local trace function, otherwise we don't. So if we try this again, if I just go next now, I will just step over to the next print call, and if I step into it, then we go inside. Next, what can we do next? I think I would like to have the ability to see a bit more context than we currently are. Right now we are only seeing one line, and I think after n, the next most, yeah, L, I first do L, and LL is just a variation, I guess, with more context. Right, so we see a bit more context rather than just the one line. And for that, we're going to need, well, we need to collect some context. I'm just going to have a list here and connect, yeah, take a subset of the lines that we got earlier, basically. So I guess, yeah, we could iterate over a range from the current line number minus some amount of lines, maybe 3, to the line number 3 lines below, and then we can append the current line. So that is lines of I. And actually, while we're at it, let's add line numbers here as well, because otherwise this gets a bit confusing. So again, the off by 1 thing and the actual line. And finally, we can print it. So print the context, all of the context with a new line separation. Let's see if this works. Right. Yes, our first error. No one was in the talk yesterday. All right. So we need to make sure that our I is is not negative, and we need to make sure that it's not too big either. So if I is less than 0 or I is larger than len of lines minus 1, I hope, then we can append this. And while we're at it, we may as no, if then we want to continue. And while we're at it, we may as well add some indication that we're on the current line number. I think this will also look nicer. So if I is the same as the f line no minus 1, then we'll do a slight variation of this, I guess. And add some arrow. All right, let's try this again. I think I'm going to step inside so I have a bit more context. Nice. And LL, I guess, would just be the same thing, just with larger numbers, but I don't think we'll see the difference in our file here. More suggestions? Otherwise, I come up with my own. Step in, we did. We could do the one thing I also used earlier was R, the return, like jump to the return value. And that's going to be a bit similar. So again, we're going to set some flag that we want to skip the turn off the debugging. However, in this case, we need to continue looking at the, like we can't really turn off the tracing entirely because we still want to get information on the return event. So I'll call it jump to return, and I have to do the same jump here, jump to return, same steps here. Also is assigned to, so there's a global variable. And now we could say if we have this active and the event is not return, then we just ironically return. Let's see if this works. I step into, I return, and we jump to the return statement. Yeah, I think this is all for today. Enough for today. There's a bunch of more things you could add. Jumping up and down frames is something that I personally use sometimes, like U and D for up and down. Could even implement goto with this in a limited way, but yeah, not today. takeaway for this talk. You can set a global trace function with sys.ztrace. You can have it return a local trace function if you so choose. There's a bunch of events. There's call, there's line, there's return and exception, and the one we don't talk about. Frames are is interpreter state exposed to Python. Has a bunch of interesting attributes. These are not all. There's a bunch of more attributes. Yeah, and very much fun to play with. And maybe the meta takeaway, I just like how introspectable Python is, so that you can do this kind of thing. In other languages, it would be at least harder, if not impossible. Making a toy version of a seemingly complex system is a very good way to understand how this works, or at least have the impression that you understand how it works. And last but not least, I love doing this kind of thing. It's a ton of fun. Yeah, that's all. Thank you very much.
Thank you, Jonathan. We have 2 questions at Slido. Just a second. First question is, I'm not sure I understand it all the way, but I'll try. What are your views on Rich for adding more readability to your nice debugger?
Could totally do this. Fun fact, these slides are implemented with Rich, so you could do that for the syntax highlight, for like showing the context in the code. That would be a cool idea. But I think too complex for 25 minutes.
Okay, and there is also a second question, which is kind of combination of an opinion and a question. So 30-minute coding to make PDB pretty. With PDB, the bug will be resolved too. What is the advantage to do that effort, except enhancing personal skills?
I mean, sure, it's not going to... I must be honest, I'm not using this for my day-to-day debugging. Of course not. It's really only to understand this better and to have fun with it. You're not going to use this, but it still helps. Like this is not the only thing I did with like re-implementing something like that. It also gives you a lot of respect for the people who actually do this. I'm sure that PDB has way more time put into it, and it shows. And there's even like IPB or other I don't know, other fancier debuggers. Obviously have way more features, but yeah, it's mostly really just to have fun and to understand more about the internals of Python.
All right. Thank you very much.
Thank you.